So we're just going to be going over the complex number questions that we're doing the other day. I feel like these are going to be the ones you're going to be asked the most of. The only thing I haven't included is going to be the complex root questions and stuff like that. They do come up, just not as often. So I feel like for this exam, if you get your basics right, it'll be much more beneficial than trying to learn everything at once, because you have this. I can't remember if you have Christmas exams or exams after the fact. But for your mocks, we'll definitely be doing more so that you know those questions. And then obviously for the Leaving Cert, we want to be nailing the basics months in advance so that we can tackle the harder stuff a lot more often. So, question 3. Z is equal to 6 plus 2i, where I squared is equal to negative 1. Part 1, show that z minus iz is equal to 8 minus 4i. As I said the other night, the best way you can write this out is just taking your time and putting brackets around all the complex numbers. So, z minus iz, that's just the way I write complex numbers when I use z, just so it differentiates it. Just because if you're writing too fast, you might do that and you're like, oh, is that 2? So this has to be equal to 8 minus 4i. Well, what is z? Z is going to be 6 plus 2i. And again, just whack them inside brackets. Minus, then we're going to have I times 6 plus 2i. And this has to equal 8 minus 4i. So 6 plus 2i, nothing happens to that just yet. Now minus, what happens when we multiply 6 plus 2i by I? Well, this is going to be minus 6i. Then we're going to have I times 2i, which is equal to 2i squared. What is I squared? Well, it's negative 1. So this is 2 times minus 1, which is minus 2. So this just simplifies to minus 2, and this is equal to 8 minus 4i. So we have 6 minus minus 2, which is 8, and you have 2 minus 6, which is minus 4i, is equal to 8 minus 4i. So that's true. So next up, part 2, show that the modulus of z squared plus the modulus of iz squared is equal to the modulus of z minus iz squared. So again, we're just going to be writing everything else. So this is going to the modulus of 6 plus 2i squared plus the modulus of, well, we've already figured out what iz is in the last one. It's going to be 6 minus 2. I'm going to write it the other way around, so it's minus 2 plus 6i, just because it's just the way you write complex numbers. And this is going to be equal to z minus iz. Well, it's this right here. 8 minus 4i squared. If we do this out, we know that the modulus of a plus bi is going to be equal to the square root of a squared plus b squared. And then we just have to remember to square that in the very end. So we have 6 squared plus 2 squared. I'm going to find the square root of that, and then we're going to square it. Plus, same again here. Minus 2 squared plus 6 squared, and we're going to square that, is equal to 8 squared plus minus 4 squared. And then we're going to square that. So 6 squared is 36, 2 squared is 4, 36 plus 4 is 40. So we have the square root of 40 squared plus, same again here, square root of 40 squared, and this is going to be equal to the square root of 80 squared. Because you have 8 squared is 64, minus 4 squared is 16, 64 plus 16 is 80, square root that, and then we need to square it. What happens when you square a square root? You get rid of it, so we just have 40 plus 40 is equal to 80, so 80 just equals 80. So far these are quite nice questions. Now, part 3. The circle C passes through the point Z, IZ, and 0 as shown in the diagram below. Z and IZ are endpoints of the diameter of the circle. Find the area of the circle C in terms of pi. There is space in the next page for your solution. I'm not going to write it down there. I'm just going to write it in beside it, just so you have the picture there to help you. So, from the last question, we have the point Z is equal to 6 plus 2i. IZ is going to be minus 2 plus 6i. So we need to find, first of all, what's this question asking? Well, we need to find the area of the circle. What's the area of a circle? It's equal to pi r squared. So we need the radius. Two ways you can find the radius. You can find the distance between this point here and this point right here. And that's going to be the diameter. Whatever the diameter is, you just divide by 2 and then just plug that into the function. The other thing we're going to use is the midpoint formula. So this, if you can remember, the midpoint is equal to, and then you have x1 plus x2 divided by 2, and you have y1 plus y2 over 2. So what is this? We're just going to be using these points. So we know that the midpoint is just going to be equal to x1, which is minus 2, plus x2, which is 6. Divide that by 2. And then I'm just going to leave the i's out of it for a second, or you can leave them in. So you have 6i plus 2i divided by 2. And this just comes out to minus 2 plus 6 is 4, divided by 2 is 2. And then you have 6i plus 2i is 8i divided by 2 gives you 4i. So this is the point 2 plus 4i. So because this is the center, and we have this point down here, which is touching the point 0, 0, we can actually use the modulus formula, because all the modulus is the distance from the center to the point, and that's going to be the radius. So if I find the modulus of 2 plus 4i, well, that's just going to be equal to 2 squared plus 4 squared, and then we find the square root of that. I'm just going to write it as the power of a half, but it's the same as writing the square root. So it's going to be 2 squared is 4, 4 squared is 16, 4 plus 16 is 20, so this is just the square root of 20, and that's going to be equal to the radius, just if you forget. So now we have the area is equal to pi times the radius squared, which is just 20 pi. And that's your answer. Now, root 3 minus I to the power of 9 can be written in the form a plus ib, where ab are integers and I squared is equal to negative 1. Use the Mob's theorem to find the value of a and the value of b. If I read that too fast, just pause the video, read it. So, if we have this, and it's telling us to use the Mob's theorem, well, what is this? It's going to be equal to or to the power of n times the cosine of n by theta plus I sine n by theta, where that n is going to be equal to the power. So here we have a power of 9. So first of all, we need to figure out what or is. Well, what is or? It's the modulus, so it's root 3 squared plus 1 squared. Find the square root of that. So it's going to be square root of 4 equal to 2. And now we defined that angle theta. So the argument of any complex number z is going to be equal to the tan inverse of b over a. So we have minus 1 over root 3, and this comes out to 30 degrees. Now we just need to figure out where this angle actually is. So over here, I'm just going to draw my x and y axis. Well, the point root 3 is going to be somewhere here, and we know that the point minus 1 is going to be here. So this right here is root 3 minus I. So I want to find the angle. The angle is always measured from the positive x-axis, so it's going to go from here all the way around. But it's the same as finding this angle here and taking it away from 360, which is what we just done. So we have to then go and say 360 minus 30 is equal to 330 degrees. Now we just fill in the formula. So we know that or is 2, and then we know that n is 9. This is going to be multiplied by the cosine of 9 by 330 plus I sine of 9 by 330. Plug those into your calculator. We get 2 to the 9 is 512. The cosine of 9 times 330 is 0. And this gets added on to the sine of 9 times 330, which is equal to 1. So there's just an I here. So then this is just equal to 512 I. So our A is 0 and our B is 512. Now we have division coming up. As you both know, the other night you got to multiply by the complex conjugate of the number on the bottom. So we have 4 minus 2i divided by 2 plus 4i. Complex conjugate of 2 plus 4i is 2 minus 4i. Same on the top. When we multiply this out, 4 by 2 is 8, minus 2 by minus 4 is plus 8i squared, which is equal to minus 8. And then we have minus 2 by 2 is minus 4i, and then 4 by minus 4 is minus 16i. So this just equals, because minus 8 and 8 cancel, this is just going to be equal to 20i. And then at the bottom, we're going to have 2 by 2, which is 4. You have 4 by minus 4 is minus 16i squared. So that's plus 16. And then we're going to have 4 by 2 is plus 8i. and then same again, minus 8i. So that cancels with that, and then we're left with 20i divided by 20i, which is just equal to I. So 0 plus, and here we have 1 times I, so k is equal to 1. Next, find the square root of minus 5 plus 12i. So there's two ways you can do this. The first is going to be involving De Moivre's theorem as always, but I'm going to show you a separate way you can do it, so that it makes not more sense, but you might be a little more comfortable doing it this way using calculus, or not calculus, using regular algebra. So any number, a plus bi, can be written as a plus bi squared. So in this case, what we have is 5, or minus 5 plus 12i is going to be equal to a plus bi squared, just gives you a squared plus 2abi minus b squared. So we know here that the real part, we have a squared minus b squared equals minus 5, and then we have the imaginary part is going to be 12 is equal to, or the other way around, we have 2abi is equal to 12i. We can get rid of the i's there, just because there's a common between them. So if we solve the imaginary one, we end up with b is equal to 6 over a, and that's because we do 12 divided by 2 gives you 6, 6 divided by a just gives you 6 over a, and now we can plug this into the other equation. So here we're going to have a squared minus b squared is 6 over a squared is equal to minus 5. So then we have a squared is minus 36 over a squared is equal to minus 5. Multiply everything by a squared, so we get 8 to the 4 minus 36 plus 5a squared. Gonna rearrange those. So if we solve this like you would do a normal factorization, we're going to have a squared plus 9, and then we have a squared minus 4. So then we have an a squared is equal to minus 9. So then we have a is equal to plus minus 9. That doesn't make sense. So if we go to the other one, we're going to have a squared minus, or a squared is equal to 4, so then a is equal to plus or minus 2. Sorry, this one should be 3. So because this bit right here, we have a squared is equal to a negative number, this is going to be the complex part of it. So therefore, we can rewrite this as either 2 plus 3i or minus 2 minus 3i. And that's because we have a squared is equal to 4 here, so 4 is a real number, but if we plug minus 2 into here, we still get 4. So this is going to be our real part, whereas over here, we have a squared is equal to minus 9. This has to be complex, because you can't square a number and get a complex number, or you can't square a number and get a negative number. So this is going to be our complex, but we still have to use the plus or minus 3. So these are our two answers. So part C. Use De Moivre's theorem to find 3 roots of z cubed is equal to minus 8. Give your answers in form a plus bi, where a, b are real numbers, and I squared is equal to negative 1. So it says give your answers, so we know there's going to be more than one. So we can say that z cubed is equal to, and then we need to use De Moivre's theorem. So it's or cosine theta plus I sine theta. We need z by itself though, so we need to take the cube root of everything on the right hand side, which is the same thing as putting everything to the power of 1/3. So first of all, we need to figure out or is. Or is going to be equal to minus 8 squared plus 0 squared, and we find the square root, so that's just going to be 8. Now we need to figure out the argument, so we know that the argument of z is going to be equal to minus b over a. So in this case, it's going to be 0 over minus 8, which is equal to pi over 3. Or sorry, it's equal to pi. Because if we look back up here, we can see that the tan is equal to 0 at either 0 degrees or 0 pi. We're not going to use that one. We're also going to use this one right here. You can use it in degrees or radians. I will always recommend using radians for complex numbers. So here we're going to have our angle as pi. So if we go back down, we can rewrite this as z cubed is going to be equal to 8 to the 1/3 multiplied by the cosine of the 1/3 goes into it. So we're going to have this whole thing divided by 3. And we're going to have pi plus, and then we need to use 2 pi n. It's just part of the formula. And the same thing happens to the sine function. We're at pi plus 2 pi n divided by 3. And we can figure this out. So, first of all, 8, the cubed root of 8 is 2. So we can simplify it. And now we just need to use the formula. So if we're using to the power of 3, we need to use n is equal to 0. We always start at 0. N is equal to 1. And then n is equal to 2. We don't do 3. So for this, it's just about plugging whatever that n is equal to into the equation. So we have 2 times the cosine of pi plus 2 pi times 0 divided by 3 plus I sine, the exact same thing, pi plus 2 pi times 0 over 3. And this simply just comes out to 1 plus root 3 I. So that's one of the roots. Same thing to the other two numbers. 2, then we have the cosine of pi plus 2 pi times 1 divided by 3 plus I times the sine of pi plus 2 pi times 1 over 3. And when we compute that, it comes out just to minus 2. Because the sine of this is going to be 0, as in this comes out to 0, whereas this comes out to 1. And then, or minus 1, sorry. So you just have 2 times minus 1 gives you minus 2. Finally, we just need to do it one more time. So 2 cosine 2 pi, sorry, pi plus 2 pi times 2 over 3 plus I sine, the exact same thing. And when we figure that out, it's 1 minus root 3i. So this right here is one root, this is the second answer, and this is your third answer. So the final question here, it says z is equal to minus root 3 plus I. Use the Mobbs theorem to write z to the 4 and form yada yada. Same again, just the Mobbs theorem. So as always, we're going to have a plus bi is equal to or to the n multiplied by the cosine of n by theta plus I sine n by theta. So we can go ahead. What's or? It's equal to minus root 3 squared plus 1 squared, which is equal to the square root of 4, it's equal to 2. Now we need to find the argument. So the argument of z is going to be equal to the tan inverse of 1 over minus root 3. This comes out to minus pi over 6. So we need to do pi minus that. So if we do pi minus pi over 6, we're going to get 5 pi over 6. And now we just fill out the formula. So or is 2 in this case. So we know that's 2 to the 4 multiplied by the cosine of n, which is 4. So it's going to be 4 times the angle, 5 pi over 6, plus I sine 4 times 5 pi over 6. And then when you compute that, what we're going to get is minus 8 root 3 I. Now, the last question, there's a couple of ways to solve it. One is using a graph, and the other one's going to be just using math, so that's the one I'm going to do. So it says the complex number w is such that the modulus is equal to 3, and w makes an angle of 30 degrees with the positive sense of the real axis. If t is equal to z times w, write t in its simplest form. So this is something you probably haven't seen before, but it's something that I remembered doing from my own Leaving Cert, because it spooked me. It took me a few minutes and then I eventually got it. So we can write, if you remember back to a while ago when I was yapping on, or if you remember from the 3 questions, we can write any number on the point of a circle as the cosine of a times the sine of a. And that's what's going to help us do this. So, all the way back down, we know that w is going to be equal to 3, which is the length of the radius, or the modulus. And inside of it, it's going to be cosine of that angle, 30 degrees, plus I sine of 30 degrees. when we do this, we're going to have that z times w is equal to 2 times the cosine of 5 pi over 6 plus I sine 5 pi over 6. And this gets multiplied by the original. So this is going to be multiplied by 3 times the cosine of pi over 6 plus I sine pi over 6. So when we figure this out, we're going to have this is equal to 6, because it's 2 by 3 gives you the 6. And inside, when you multiply these out, we have the cosine of pi plus I sine pi. And that comes from your rules, because if you multiply two cosine angles, we add what's inside of them. So you have 5 pi over 6 plus pi over 6, which just gives you 6 pi over 6 equal to pi, and the exact same thing happens to the sines. Now we just figure this out. The cosine of pi is -1, and the sine of pi is 0. So here we're going to have 6 times -1 plus 0i, which is just equal to -6. And that's what your t value is going to be.